All right, so coming up in the second video of chapter 9, we're going to continue on doing more examples and looking at the various types of one sample hypothesis testing that we can do. So if, and hopefully you did, watch the first video in chapter 9, 9a, I want you to pause this video and try example 3 on your own. All right, so well, hopefully you went ahead and did that. So example 3 says, farmer says that female-owned farms in Michigan sell about $16,000 worth of goods per year. We can use Isabella County as our cluster sample. So we're taking a sample, our sample from all the state of Michigan is Isabella County. As a sample, Isabella County had 116 female-owned farms, which averaged $14,436 in sales. Assume that the sample standard deviation is $8,000. Is there sufficient enough evidence at the alpha equals 0.01 level to conclude that the average sales are different from the farmer's claims? So, setting this up, the null hypothesis is going to be the average, and in this case we're talking about average amount of money sold on female-owned farms. So the average amount of money is $16,000. That's the claim that's being made. Our alternative, got a little tongue-tied, hypothesis is that the average amount, well, it says different. So the average amount is going to be not equal to the $16,000 that the farmer claims. All right? Now, in this case, we're talking about averages. We have a sample standard deviation. So since we have a sample standard deviation, we're going to utilize a t-test. Again, in the real world, most of the time we don't have a population standard deviation. So most of the time in the real world, we utilize t-tests rather than z-tests. But again, you'll find some on these problems where we utilize the t-tests. Now, we go in and to utilize the t-test because we have a sample standard deviation given to us. And our mu sub 0 is going to be 16,000. The x bar is going to be 14,436. That's the sample average. The sample standard deviation, which is S, we write as 8,000. My N equals 116. That's how many farms there were, sampled 116 farms. And I'm going to utilize the not equal feature because our alternative hypothesis has not equals. So when you go ahead and do this, the display screen on your calculator should look like this, right? 16,000 for your mu sub 0, 14,436, 8,116, not equals, and then we're going to calculate. Now, once you hit enter on your calculate, you get this. My p-value is 0.0374. So the p-value that we're going to use, 0.0374. Now, let's compare that to the alpha. In this case, the p-value is greater than the alpha. So this is the first time we have p greater than alpha. And so p greater than alpha versus p less than alpha means, well, how far was our sample average from our guess? In this case, Our sample average, we would say, is far from our guess. So we would, did I say far? Close enough to our guess. So we're going to do not reject the null hypothesis. Again, I tend to write do not reject H0. Again, if you want to write out the words the null hypothesis, that's okay too. All right. So P is greater than alpha. Do not reject the null hypothesis. Now, if we don't reject this, okay, so we're not rejecting this. We're saying that this could be true. All right. So this is okay. So how would we interpret a statement like that? That null hypothesis is okay. Now I know what you'd want to do. Like previously we just read off. Here we're going to say, well, the average sales on female-owned farms in Michigan is, I don't want to say equal to. That's the whole trick of this do not reject scenario. We're going to say is close to $16,000. Now, notice that I avoided the equal to language on this. I'm doing that on purpose. Let's go back to the notes for just a moment and go back to what we did last time. This comes back to the proper language. So even in our interpretation, we said essentially not guilty, right? That's what do not reject H0 meant. If I said that the average sales was equal to 16,000, that would be the equivalent of me saying innocent. I don't want to say innocent. I want to say not guilty. So I know it's a little bit of a ticky-tack thing, but we don't want to say for sure we know that 16,000 is the amount, average amount on female-owned farms. We want to say, well, we know it's pretty close to 16,000, right? Our data suggests that it's close to 16,000. And so that's how we interpret that statement or that conclusion. So do not reject. So we're saying that this is okay. So the average sales on female-owned farms in Michigan is close to 16,000. All right. Let's do another. Once again, read this, push pause, read this, and try to do this on your own. All right, so hopefully you paused it and tried it. Large university reports that the average salary of newly hired professors is $70,000. A faculty member wonders if that is higher than most other universities. A survey is done, and in 34 institutions, the average salary was $67,750, with a sample standard deviation of 15,000. Can the faculty member conclude that the average salary at universities is less than 70,000? And we're going to use alpha equals 0.10. So we go back to our example, or excuse me, to our Word document. I'm going to increase the font on that a little bit. There we go. So null and alternative hypothesis. You should have had that the null hypothesis is that the average salary is equal to 70,000. The alternative should be that the average salary is less than 70,000. Again, this comes from the fact that in the problem itself, it says, can we conclude that it's less than 70,000, right? The test we're going to use is a t-test. So when I go into my calculator and utilize the t-test, we're going to use statistics again. 70,000 is my mu sub 0. My average, 67,750. My standard deviation, 15,000. And my sample size here is the 34 institutions. Now we're going to use less than mu 0 as the what is that? Fifth entry line down. So when you do that, your calculator is going to look like this. All right, you can pause that if you need. You calculate that, and you get a p-value of 0.1940. 0.1940. Again, off to the side, I like to write real quickly that means that p-value is bigger than my alpha. Okay, you don't have to do that on the test, but p-value is bigger than alpha. So this is, again, a do not reject the null hypothesis. If you want to write the words the null hypothesis, that's fine. Most of the times I just write H0 to mean null hypothesis. So do not reject the null hypothesis. So what this means is that the average salary of all institutions or I should say the average starting salary of professors for all institutions is, again, we want to use the word close to rather than equal to $70,000. Okay, so the average starting salary of professors for all institutions is close to $70,000. Let's go to the next example. Again, as always, I want you to pause this and try it. Okay, so football coach says that the average number of injuries per year in collegiate football during games is roughly 18,000. This was actually, there's a study done over 5 years, and they found that the average number of football injuries during competitions was 19,982. Assume that the population standard deviation is 400. Determine whether the average number of injuries is actually more than what the coaches claimed. All right. So here it is. Once again, we go to the null hypothesis first. Null hypothesis, we always want, by the way, this is the way we always want to do things because that's going to make most sense when we turn to go into our calculator. Some people, oftentimes, I'll see make a mistake of turning to their calculator first before they write the null and alternative hypotheses. So make sure you're writing null and alternative hypotheses first. Null hypothesis is that the average number of injuries per year is 18,000. The alternative hypothesis is that the average number is well, we're saying actually more than what the coach claims. So is it more than 18,000? All right. Again, so is the average number of injuries more than 18,000 or is it close to 18,000? That's how we're going to interpret that. Now, this test, we want to use a z-test, and that's because I know the population standard deviation. So because it says I know the population standard deviation is 400, or I'm assuming it is, then that's why we use the z-test. Entries on the z-test: mu sub 0, 18,000. Sigma, your population standard deviation, is 400. 19,982 is our sample average. My n, well, we only did this for 5 years, so it's a fairly small sample size. So n is 5, and we want to say is actually more. So we're going to use greater than mu sub 0. Once again, just to show you my calculator screen, it looks like that. Push pause if you need, but that's what it is. So we go ahead and we calculate that. Notice what that p-value is. That p-value is a scientific notation. When we get a p-value that comes out as a scientific notation, we're just going to write it as scientific notation, right? 8.07 times 10 to the negative 29th. Now, if you were to write that, or if you were to actually even attempt to write that as a decimal, you're going to have 28 zeros there when you write that p-value before you put that 807. So this is an extremely low number, and this happens sometimes on the p-value. Sometimes you get a p-value that's really, really low like this one. And all we have to do is recognize, oh yeah, scientific notation, p is less than alpha, and so we still reject. By the way, sometimes your p-value can be so small that the calculator can't recognize it. Let me put it this way, that the calculator recognizes it as 0. So sometimes you'll get a p-value which is 0, and that just means it's so small that there's basically no chance of being that the claim is correct. So this is a reject H0, and this is a hard reject, right? We're saying this cannot, we're pretty sure this is not true, okay? It's a very, very small probability that H0 could be actually true. So this says that the average number of injuries per year in college football competition is more than 18,000. Okay. Now there is something that I want to mention about this problem as well. Notice that our sample size was really, really small. Our sample size was 5. That is actually not a really great sample size. Normally, we want our sample size to be either 30 or more, or we want our sample size, if it is small, we want to make sure that the central limit theorem can still apply. In other words, you want it to be either 30 or more, or you tend to want to already know that the population standard deviation, that the original data is normally distributed. Okay? So 5 is something we kind of want to avoid in statistics, but just like I did, if you're given example on the test and it says do a test and you've only done 5 years, it's perfectly fine to go ahead and do the test the way we normally would. Okay, but again, in practicality, you wouldn't want to take and try to conclude a sample based on 5 years or an n equals 5. Okay, hopefully that makes sense. 5 is a pretty low number. Okay, let's look forward at the next example. So a student claims that the Mount Pleasant City Police issue an average of 60 drinking tickets per day of a football game. These data show that the number of drinking tickets issued each day for all home football games over a period of 2 years. Is there enough evidence to reject the student's claim at alpha equals 0.05? Now, the difference between this example and previous ones is in this example we have raw data. Rather than giving statistics, we're given raw data. Now, once again, don't think that we turn immediately to our calculator. Once again, we want to set up, before I even turn to my calculator, set up the null and alternative hypotheses. So the null hypothesis in this case is that the average number of tickets, in this case drinking tickets, is equal to 60. All right. The alternative hypothesis, well, this one doesn't say anything about greater than, less than, anything like that. So it's saying that the average number of tickets is not equal to 60. Then we ask ourselves, what test do we use? Okay. Now, in this problem, it doesn't have we have a sample of 14 pieces of data. Don't get confused. 14 pieces of data, not 2 years, but 14 actual pieces of data. But it doesn't say anything about a population standard deviation. These 14 pieces of data will have a sample standard deviation, but it doesn't give me a population standard deviation. So since the data will have a sample standard deviation, but it will not have it will not tell me the population standard deviation, I want to use a t-test. Okay. Now, before we actually go into t-test, we are going to have to put this data into our calculator. So what you'll do is you'll go to Stat, Edit, and then into List 1, you're going to type in all 14 pieces of data. And I'm typing that in right now. If you need a couple of more seconds, you can always pause the video and type in those 14 pieces of data right here. Okay? So again, on my calculator, I have all of those 14 pieces of data into list 1. Okay. So once I've done that, then we go to my t-test. All right. Now we're going to have the input of data. So you're going to switch over that very top entry where it says data or stats. You're going to put that on data. The mu sub 0 is going to be 60. That's the number that is in my alternative and my null hypotheses. My list is going to be L1, again, second L1. Frequency, just leave as 1. And then the alternative hypothesis has not equal to. So we're going to utilize the not equal to feature on the calculator. So as far as the inputs go, you probably could have figured this out if I didn't say anything, but that's what your calculator should look like with the inputs. Okay, so calculate, And I got a p-value of 0.3696. So my conclusion is that I should not reject the null hypothesis. Do not reject H0. Again, that's because this p-value is bigger than the alpha that I'm given. So if p-value is bigger than the alpha that you're given, we do not reject. If p-value is smaller, we reject. Now, do not reject the null hypothesis meant that that's probably okay. So the average number of speeding tickets issued per game day is close to 60. Number of, I'm sorry, not speeding, drinking, right? Drinking tickets issued per there we go. So average number of drinking tickets issued each day for home football games is close to 60. So this shows us how to utilize data. We've done a number of examples where we've utilized statistics, but always the determination between a z-test and a t-test is if we know the population standard deviation, we go with z. If we know the sample standard deviation only, we go with t. Now, this next example I'll do here, we're not dealing with averages anymore. An anchor on a news program reported that 65% of American teens say that anxiety and depression is a major problem among their peers. The Pew Research Center did a survey in 2018 and found that 646 out of 920 teens said that anxiety and depression is a major problem among their peers. So we're going to test the claim that the anchor made, and we're going to test it at alpha equals 0.05. Now, the first glaring difference between this one and the previous 6 examples is now we're dealing with proportions. All right. So once we get to our calculator, we will use the one prop z-test. We'll use the proportion test. But before we do that, we have to realize how to create the null and alternative hypotheses. Okay, so null hypothesis. The claim is that 65% of teens say this is a major problem. So what we're saying is that the claim is that the proportion who say it's a major problem is equal to 0.65. Be careful that you don't put 65. That won't take on the calculator. Prop equal to 0.65. By the way, if you're wondering why I'm using PROP rather than just the letter P, well, because we have a p-value down here, so I don't want to get the p-value confused with the proportion that I'm testing in my problem. So that's why I'm using PROP in my null and alternative hypothesis as a short for proportion rather than just using the letter P. Okay, so I don't get that p-value confused with proportion. Okay, now this doesn't say anything about less than, greater than, larger, smaller. If it did, we'd use the less than or greater than symbol. But this one simply says, is the proportion of teens who say that close to 0.65, or is the proportion not that? So not equal to 0.65. The test we're going to use is a one prop z test. And you can imagine where to find that. Stats, tests, just like we've done so far, hit the stat button, test one prop z test, and go into it. Now, hopefully you can understand what P sub 0 is. P sub 0 is the 0.65. And then we have an x and an n. This is the exact same x and the exact same n that we had in the last chapter. In chapter 8, or to me, yeah, in chapter 8, we talked about x is the number of successes. So the x value here, in this case, would be 646. And n is the amount of people in the study. So it's 920. We're going to use the not equal to, and there you go. So once again, if you're looking at this on your calculator, your screen is going to look like this. All right. So P0, X, N, proportion, and then we calculate. Now, once we calculate this, what you'll see is you'll get a few different numbers. Notice we have a P hat and a P. The P hat is simply the proportion of your sample. So 646 out of 920, that was the P hat value. The P value, which is the one we're trying to look at, is the 9.07 times 10 to the, let me write that down in scientific notation, 9.07 times 10 to the negative fourth. Okay, that's a very small number. That one's not so many zeros that you couldn't write it, but I'll just leave it as scientific notation if my calculator gives it to me that way. And so this p-value, whoops, is less than alpha. Okay, my alpha is 0.05. That p-value is clearly smaller than 0.05. P-value less than alpha means we should reject the H0. Again, if I reject H0, I'm saying this can't be true. I keep doing this, draw a line through it, but again, on the test, you shouldn't necessarily do that. So we reject this. So we're saying the proportion of American teens who say this is not equal to 0.65. And that's how we would interpret that. The proportion of American teens who say that anxiety and depression is not equal to 0.65. That was a long statement, but you get the point. All right, that was a long statement that they had to agree with or disagree with. So the proportion of American teens who say that anxiety and depression is a major problem is not equal to 0.65. So hopefully you understand how to do a proportion test. So here's what I'd like you to do. I'd like you to read this problem and try it. Push pause on the video, read it, and try it. All right, so here's the deal. Pew Research Center did this survey and found that 7.3% of the children, K-12 students in the U.S., were children of unauthorized immigrants in 2014. Principal wants to find out that if her school district has the same percentage. All right. She randomly selects 1,000 students in her school district and finds that 76 are students of unauthorized immigrants. Using alpha equals 0.05, does her district have the same percentage of unauthorized immigrants as the Pew Research Center found? So, null hypothesis. Null hypothesis should be that the proportion is equal to, be very careful when you write these proportions as decimals. When we go 7.3%, that is 0.073 numerically. It doesn't say anything about greater than or anything. It says, is it the same or not? So the proportion not equal to 0.073 is going to be my alternative hypothesis. All right. Again, if you put mu equals 0.073, that's going to be labeled, or that's going to be counted as incorrect when you do that on a test. All right, you need to write prop when we're talking about proportions, and you need to write mu when we're talking about averages. Test, this is a proportion test, so it's 1 prop z test. If you were to write proportion test, I'd have counted it 2, that's fine. And then once you go and into your calculator and do the test, again, stats test number 5 there, 0.073 is your P0, your X value is 76, your N is 1,000, and you're going to choose not equal to. So once again, on the calculator, don't have that square, but keep it steady there. There we go. So once again on the calculator, that's what the screen should look like. P-value comes out to 0.7153. 0.7153. That is a very large p-value, so that's actually very close. And so that p-value is very large. P is greater than alpha. And so if P is greater than alpha, we're going to say that the proportion of unauthorized, or of children, the portion of students who are children of unauthorized immigrants in her district is close to 0.073. That's a little bit wordy of a statement, but the proportion of students who are children of unauthorized immigrants in her district is close to 0.073. You could have also said it's close to the national average that the national proportion that the Pew Research Center found. All right, again, the key things here, there's a number of ways you can say this, but the key things here is that we are using the word proportion, and we're using the phrase close to instead of equal to. All right, those are the two big ones. Oh, did I say? Ah, shoot. I apologize for that. I made a mistake. I wrote that as the conclusion. I should have wrote that as the interpretation statement. Okay. The conclusion, I said, is do not reject H0. I didn't write it down that way. When I write this down on the board, I make a little bit fewer mistakes, but that's okay. It's easier to erase on the board. But there you go. Conclusion is do not reject H0 because p-value is big, at least bigger than alpha. And then the interpretation statement, what I said, the proportion of students who are children of unauthorized immigrants in her district is close to 0.073. Okay. Once again, we're trying to mimic what things we talk about in previous chapters and those things. Oops. All right. So I'd like you to, again, pause this, take about 5 seconds, and do this problem. All right. So Rasmussen reports said that 70% of American adults say that their religious faith is at least somewhat important. So there's gradations to this. There was something somewhat important, really important, that was the kind of thing. So 70% say that their religious faith is important, at least in some ways, in their daily life. Political candidate from Michigan says that Michigan has the same percentage. A sample is done, and it's found that 55 out of 80 people in Michigan say their religious faith is at least somewhat important. So we're going to test the candidate's claim at alpha equals 0.02. All right. So let's set this up. Candidates claiming that the proportion of people in Michigan is the same as the national average. So the prop equals 0.70. The alternative is not equal to. Is that the proportion of people in Michigan is not equal to 7. Person who think that their religious faith is important is not equal to 0.70. Again, that at least doesn't refer to at least this number, just means, important or not, a little important or not. The test, again, I'm going to write one prop Z test. If you want to write proportion test, that's fine. Our inputs on this, the P0 is going to be 0.70. The X is going to be 55. The N is going to be 80. And once again, we're going to use the not equal to. All right. So when we type this into our calculator, my calculator is going to look like this. All right. Okay. So we go ahead and calculate, and the p-value, once again, turns out to be really big, 0.8073. I say really big. P-value, remember, is an area under a curve, so the most it can be is 1. So 0.8 is a pretty big p-value to have. And all we care about is if the p-value is bigger than alpha. 0.80 is definitely bigger than 0.02. So because p-value is bigger than alpha, we do not reject the null hypothesis. Do not reject H0. Now, what are we saying when we do not reject H0? This proportion stood for the proportion of people in Michigan who say their religious faith is important. So the proportion of people from Michigan who say their religious faith is. So the proportion of people from Michigan who say their religious faith is important is close to 0.70. All right. And that's it. Portion of people in Michigan who say their religious faith is important is close to 0.70. Again, you can add sort of more or less language depending on how precise and detailed you want to be. The important parts are that we're dealing with proportions, and do not reject means we're going to write is close to. We could have said is important to their daily lives. So if you wanted to write it and be a little bit more precise, or you could say is at least somewhat important. Instead of saying is important, you can say is at least somewhat important to their daily lives is close to 0.70. Either any of those phrases that I just said would have worked, all right, for the test. Now, the last thing I want to mention is that now we've done hypothesis testing officially on averages and proportions. You can also do hypothesis testing on standard deviations and variances. We're not going to do that in this class. We're going to skip over that. That utilizes something called a chi-squared test and a chi-squared distribution. Actually, in our book, that's chapter 11, and we skip over that stuff. So I just wanted to mention that the most popular testing we do is for proportions and for averages. You can do testing on lots of other things too, but we're just going to focus on proportions and averages in this class. So that's the end of chapter 9. And make sure, again, you stay on top of the homework, stay on top of everything.